Hello everyone, welcome back to another lesson in our machine learning series. Today we're going to be talking about data preparation and something known as EDA, which is exploratory data analysis. So properly preparing your data is kind of a job all on its own when it comes to machine learning, and it is essential before you can actually start properly working with the data. The data, it needs to be properly cleaned up, which is what we're going to be taking a look at in this lesson. So why does data preparation matter? So imagine trying to build a house with warped lumber. So no matter how advanced your tools are, the structure is going to be unstable. And so the same logic applies to machine learning, because poor data is going to lead to poor models and poor results and poor outcomes because the data was already poor. So here's what we call dirty data examples, or poor data examples, as opposed to clean data. So one problem that we often come across is typos or inconsistencies. So are we wording the word color, COLOR, versus color with a U? Other inconsistencies we may come across is deviances in the measurement or metric that we are using to measure, say for example, height. Are we using meters? Are we using feet? Are we using centimeters, millimeters, etc., etc.? Other examples of dirty data is when we have missing values, when there's simply just a blank cell in a spreadsheet. So we may have a customer, we've got a name, we don't have, for example, their gender, and we don't have, for example, their age. We don't have, for example, what their career is. And so if we have too many missing fields, maybe we might just want to remove that field altogether. Or if we maybe have one missing field, we may be able to, there's different methods which we'll get into as to what you do when you have these missing values. How do we clean up this data? And there's a few different options which we can take in order to make the data more clean, workable, usable. Thirdly, we have something known as outliers. So outliers are essentially anomalies within the data, and they are usually extreme values that can end up skewing or distorting the results. Like for example, a random user who spent 1 million hours on an app, whereas if you imagine we have users who spend maybe 50 hours on the app, 20 hours, 5 hours, but then you've got this random case of someone who spent 1 million hours on the app. That's really going to create a distortion in the whole results. So unclean data, it can result in inaccurate predictions, misleading findings, and a huge time sink for debugging, trying to figure out what has gone on. So common data pre-processing steps. Data cleaning. So there's different types of data cleaning that we can do. We mentioned a few of them. So we can fix or remove things like typos, duplicates, and anomalies. How do we handle missing values? So we can do something which is known as a method known as imputation, where we can find a mean within the data, mean average or median average, or some other kind of special marker. Or if it's appropriate, we just remove that segment of data. Next, we also have data integration. So this is combining data from multiple sources, such as we could merge a customer info file with a transactions database into one complete data set. And we can look at things such as data transformation. So these all come under data transformation. We have scaling and normalization. So this is converting all numerical fields to a 0 to 1 range, or using something known as z-score standardization. So z-score standardization is, we kind of mentioned it previously, where we're trying to get everything under the same scoring system. So imagine you have a class of 30 students and you have 2 separate teachers. But these 2 separate teachers, they're going to be marking based off of their own different scoring system, their own different grading criteria, right? And so for a pass mark for one teacher, they may say 60% is a pass mark, but for the other teacher, they say 65%. And so this is going to create a disturbance, an inaccuracy in the results. Okay? Next, we also have something known as encoding. So we've got 2 different types. You've got one-hot encoding and something else known as label encoding. And label encoding refers to when there is an implicit or inherent, valid value system to what we're talking about. So I'll give you an example. If I say we've got 3 different categories, we've got low, medium and high. Low, we can attribute a number 1 to low, and that means correspondingly medium will be 2 and high will be 3. But what if I say I have blue, green and yellow? Is blue number 1? Is green number 2? Is yellow number 3? There's not really an inherent value system implied to that. So one-hot encoding refers to things such as like city names or product categories. There's no implicit value system that we can really place upon that, right? We don't have an implicit value. It's something that we can attribute, we can give to it ourselves. And there's also something known as feature engineering. This is things such as creating new features from existing data, like extracting a day of the week from a timestamp, for example, or deriving a BMI, which is body mass index, from height and weight. But we'll explore this deeper in subsequent lessons. Right, so EDA, exploratory data analysis. What is that? So EDA is an opportunity essentially to peek under the hood of your data set, where you'll be looking for patterns, relationships and potential problems before diving into modeling. EDA helps you understand your data structure and identify important relationships before you start building out your models. So essentially, EDA is looking at our data and seeing what different things we can derive from that data, what we can interpret, what we can extrapolate from that data. And so we have different techniques as to how we can gain an inference from this data, such as descriptive statistics. So again, things like mean, median, mode, standard deviation, which can help you better understand distribution and the variability of your data. We have data visualization techniques. So we have things such as histograms, where we can look at the distribution of ages or incomes, for example. We have box plots to spot outliers, again, to spot anomalies. We have things like scatter plots, which we can use to see the relationships between variables like salary and how that corresponds to the years of experience that a person has. And we have correlation heat maps to see how features relate to each other. Identifying outliers and missing data. Outlier detection. Spot extreme values that could throw off your model. And missing data patterns is where we're looking for patterns of missing data. Are certain columns missing more than others, for example? So how do we handle missing or skewed data? So with skewed distributions, we have an example here. So let's say we have a data set of housing prices. You'll often see a few mega mansions priced way above average, which will create a skew. And so we have something known as a log transformation technique, or log transform, which we can use for heavy skews to help create a more normal-like distribution, which will improve some models' performance. So we won't get too technical into this at this moment, but say for example you have majority of your houses placed in one section. So let's say that's between 200k and 400k. So a lot of the points on your, let's say, your graph are going to be plotted between this 200k and 400k mark. Some maybe 200, maybe some 250, some 300, some 400 there. But then you've got a few mega mansions which are priced in the millions. So this will create a skew of some of the data. So if you used to draw a line plotting all the data, a lot of the data is close together, so that line is going to be quite steady, but then it might just skew off suddenly to the right because you've got so many well, not so many, but you have a few anomalies, a few mansions which are throwing off the price essentially. So a log transformation essentially helps to more normalize that data and create more of a balance essentially. But we'll look at this in further lessons. Next, we have a technique known as model-based imputation. So this is used to predict missing values using other features. So when you have a missing value, we can use model-based imputation or simple imputation. We'll start with simple imputation more because it's easier to understand. So let's say you have a few missing values in your data. We can fill in this missing value with using mean, median, or simply labeling it as unknown if that is feasible for the data set. So to give an example, let's say we had, let's say we had a list of transactions, and one of the fields, let's say the career field, was missing. Actually, no, scrap that. Better example. Let's say we want to know what type of music people listen to, and from our data we can see that boys that are aged 21 to 25, they tend to listen to hip hop. And so we have a boy, we know that he's a boy, we know his name, but we don't know, we also know his age. We said, let's say he's 23, but we don't know what type of music he listens to. This field is blank. And so we can see that from the data, 80% of the boys that are aged within this range, they listen to hip hop. So based on model-based imputation, we will predict this value and give it the value of hip hop based on the fact that we're using the existing data that we have in order to populate this missing information. Simple imputation is to simply fill in that data with mean, median, or unknown. So either we're labeling it unknown, or mean, we're adding up all the values that we have and dividing it by the rest, or median, we're finding the middle value, and that's the value that we're going to give. So it's all just about averages, or you can simply delete that row altogether if there are too many missing values. So say, for example, using the same example, we don't know if this person is a boy or a girl. Perhaps maybe we don't know their age, and so there's just too many missing values for us to then go and start guessing away. It's much easier, much more accurate to simply delete that piece of data, as we just don't have enough information. Tools and libraries for data preparation and EDA. Python and pandas. We also have something known as NumPy, Matplotlib, and Seaborn, and also Jupyter Notebooks. So you can think of tools like pandas, NumPy, Matplot libraries as, well, these are all what are known as libraries, and they are essentially toolkits that we can use in order to perform certain functions. So the go-to library for data manipulation, data frame operations, and merging data sets, filling missing values, etc., etc. So the Panda library within Python has certain tools that allow it to be easily adapted for data manipulation, as they are essentially pre-built tools. You can think of it as a way, say for example you have a screw that you want to screw in. You could use a screwdriver, but it will take you a much longer time, as opposed to if you had the necessary tools such as a drill, where you could do things much faster, much more efficiently. So these are essentially what libraries are for and how they help to aid us in our workflow. NumPy for numerical operations, array manipulations, and efficient math. Matplot library and Seaborn. These are for things such as core plotting libraries for creating histograms, scatter plots, box plots, and correlation heat maps. Then we have Jupyter Notebooks. It's an interactive environment to run code, visualize data, and document findings all in one place. So it's very similar if you was there in the previous lessons where we looked at Google Colabs. Jupyter Notebooks is essentially another version of Google Colab. It's also free. The main difference is that it runs offline and on your own resources as opposed to in the cloud. Pro tip, keep your EDA code organized. Notebooks can become messy if you don't structure them well. Use version control, for example, GitHub, to track changes to your notebooks. So here's an example workflow of working with data, but we're going to look at this very quickly in the next lesson. And so just to wrap up, some key takeaways. Essential preparation. Data preparation is not optional, it's essential for robust machine learning results. EDA helps you understand your dataset structure, spot anomalies, and plan your next steps. Use tools like Pandas, NumPy, Matplot library, and Seaborn to streamline your workflow. And data quality, so always check for missing or skewed data and handle them in the appropriate manner, as we have previously discussed. So that pretty much wraps up for today's lesson, and I hope that you've learned a lot, and I'll see you over in the next one. Bye bye.